Good day, Doctor. Today I'm going to present on our project on developing an intelligent environmental monitoring system. This system is designed to enhance life quality by automating the monitoring and management of environmental conditions. At the heart of our system is the SKIH3113 MCU microcontroller, which collected the data from various sensors to monitor the temperature, humidity, and harmful gas concentration. One of the key features of our system is the ability to control a relay that simulated a fans for air circulation based on the collected data. Alright, so for our first objective is to automate environmental monitoring. We aim to develop a system using the ESP8266 MCU and sensor that can continuously monitor crucial environmental parameters such as temperature, humidity, and harmful gas level. This automation ensures that data is consistently gathered without the need for manual intervention and provide the real-time analysis into the environmental condition. The second objective is to implement the real-time data processing and analysis. This system will be analyze the collected data to derive the available insight. Based on the predefined threshold, the system will be automatically trigger a relay to control fans. This response of mechanism is crucial for maintaining an optimal air circulation to ensure a safe and comfortable environment. Lastly, our third objective focuses on the user interface and control. We aim to create a web interface that allows users to visualize the sensor data and monitor the trends. Additionally, the interface will provide the functionality to switch between the automatic and manual control modes for the system. This ensures that users have the flexibility to intervene and make adjustments as needed. This may be enhancing the overall user experience with our web interface. Alright, so let's continue to check out our breadboard view and hardware component. The first component is the ESP8266. The role of this ESP microcontroller serves as the central hub of our system. It is responsible for collecting data from the sensor, preprocessing this data, and communicating with the backend server. It manages the sensor data collection, Wi-Fi communication, HTTP server setup, and the relay control logic. Essentially, it orchestrates the entire operation of our system to ensure the smooth and efficient of performance. Alright, so let's continue to the second component, which is the DHT11 sensor. This DHT11 sensor is crucial for measuring the temperature and humidity levels. It provides a real-time environmental data to the ESP8266. This data is essential for making the informed decision about when to control the relay to activate the fans to ensure the optimal environmental condition. Let's go to the component 3, MQ135 sensor. This MQ135 sensor, the gas sensor, is to monitor the gas concentration, specifically for the CO2 level, to assess the indoor air level quality. It sends the air quality data to the ESP, which then used to be decide when comes to activate the ventilation system. This helps to maintaining a healthy indoor environment. So let's go to the component 4, the relay module. The relay module controls the external device such as fan to regulate the environmental condition. It is activated by the ESP based on the sensor data. The activation can be automatic and can be based on the predefined condition or manual through the web interface we have developed. The fifth component is the LED display. The LED display shows the real-time sensor status and system information. It provides a quick glance of view of current environmental condition and the system status to allowing the user to monitor the system performance easily. Other than hardware component, we have also back-end server component. This back-end server handle the data storage processing and serve the web interface. The PHP script on the server process incoming data store it in the MySQL database, and manage user interaction through the web interface to ensuring the smooth and efficient system operation. And continue to the MySQL database. The MySQL database stores the historical sensor data for analysis and monitoring. It maintains the records, temperature, humidity, and CO2 level, which are used for the train analysis and making informed decisions about the system operation. Last but not least, we go to the web interface. The web interface provides a user-friendly platform for monitoring and controlling the system. It displays the real-time and trends of the data analysis and allows the user to switch between the automatic and manual control modes. This ensures that user can interact with the system and control with the system easily and effectively. Continue with the data flow and processing step. The system will begin with the initialization of ESP8266 when it's powered on. The microcontroller establishes a Wi-Fi connection and set up a HTTP server to manage the incoming requests. The sensor initialization and data collection. Simultaneously, the DHT11 and MQ135 sensor started to collecting the data. The DHT sensor measures the temperature and humidity, whilst the MQ135 sensor monitors the CO2 levels. This sensor periodically will be transmit their reading to the ESP8266. For the data processing, upon receiving the raw sensor data, the ESP will be processed the information. It evaluates the environmental parameter against the predefined threshold. If the system is in the auto mode, the microcontroller decides whether the activation of relay to control the external device like fans to ensure the optimal air circulation. Comes to data transmission, the processed data is then transmitted via the HTTP request to the back-end servers. Here the PHP script will handle the storage of sensor reading in a MySQL database. This ensures that all data is logged and can be accessed for further analysis. Next is the user interaction and control. User interact with the system through a web interface which provides the real-time data and trend display using Ajax and also chart.js. This interface allows the user to monitor the environmental condition and analyze the trends over time. For the mode switching and also manual control, user can switch between auto and manual modes through the web interface. In manual mode, they have a direct control over the relay and provide the flexibility in managing the environmental condition according to their preference and needs. My project firmware consists of 6 key components. First is the Wi-Fi connection. Connects the ESP8266 to the Wi-Fi network to enable for the communication within the back-end server. Second, HTTP server setup. Initialize an HTTP server to handle the web interface request for remote interaction. Third, sensor reading. It manages the periodic of collection of data from the DHT11, temperature and humidity, and also the MQ135, the CO2 sensor. Next is the data transmission. To send sensor data to the back-end server for storage and analysis. Let's continue is the average calculation. It's compute average value to monitor the trend and assist in decision making. Last but not least is the relay control. Automate relay activation based on sensor readings such as turning on and ventilation system. If CO2 are higher or even with the modes, the user can turn into the manual to trigger the relay manually. Let's continue with project of backend server-side PHP script that I have developed for this system. Submit data PHP. This script handles the incoming data from the ESP8266 and store it in the MySQL database. Next is fetch last reading.php, which retrieve the latest sensor reading from the database for display on the web interface. This format will be retrieve the data into a JSON object and send it as a response to the HTTP to get request. Next is the calculate average.php. Calculate the average value for temperature and CO2 level based on the recent data entry. query the database for the last 10 sensor reading to compute this read average. Last, fetch for the average reading. .php is fetch the calculated of average reading from the database for display on the web interface. It sends the JSON object as a response to the HTTP GET request, which can be used to show the data on a line graph within the web interface to check on the data insight and analysis.